Welcome. In this presentation, we will explore the Central Limit Theorem, one of the most important theorems in statistics. The Central Limit Theorem explains why averages are normally distributed. It is the most important theorem in statistics. So, what exactly is the Central Limit Theorem? In simple terms, as the sample size increases, the distribution of sample means approaches a normal distribution. This holds true regardless of the shape of the original population distribution. A sample size, typically of 30 or more, is generally considered sufficient for the Central Limit Theorem to apply. Let's look at the magic behind the Central Limit Theorem. Imagine you have an original population with any shape of distribution. Now, when you calculate the means of multiple samples taken from this population, these sample means will tend to form a normal distribution which looks like a bell curve. Delving into the mathematical foundation, the Central Limit Theorem can be expressed as x, which represents the sample mean, follows a normal distribution, denoted by the letter n with a population mean of mu, and a variance of sigma squared divided by n. Here, sample means follow a normal distribution with the population mean, and a reduced variance. The population mean is represented by the symbol mu, and the standard error squared is represented by the symbol sigma squared divided by n. The standard error is equal to sigma divided by the square root of n. Larger samples result in a smaller standard error, which leads to more precise estimates of the population mean. Let's look at a simple Python simulation to visualize the Central Limit Theorem. We start by importing the NumPy library as np. Then, we generate sample means by creating an empty list and then looping 1000 times, generating a sample from an exponential distribution with a scale parameter of 2 and a size of 30. We then append the mean of each sample to the sample means list. Finally, we plot a histogram of the sample means with 50 bins. The result is a bell-shaped normal distribution. The Central Limit Theorem has numerous real-world applications. For example, in manufacturing processes, it is used for quality control to establish confidence intervals and monitor processes. In opinion polls, political surveys rely on the Central Limit Theorem to calculate the margin of error. Here are the key takeaways from this presentation. Sample means become normally distributed regardless of the population shape. The Central Limit Theorem serves as the foundation for confidence intervals and hypothesis testing. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.